Hello, welcome everyone. Welcome to my YouTube channel. My name is Aditya Maurya, currently pursuing BE in Sri Venkateswara College of Engineering, and my USN ID is 1VE23CK004. So today we will be discussing a question in CAD, that is Computer Aided Engineering Design. So we discuss the question that is given here. We'll read out the question and then we'll try to project it into the solid edge software. So a line AB 80 mm long has its end A 20 mm above the HP and 30 mm in front of VP. It is inclined at 30 degree to HP and 45 degree to VP. Draw the projections of the line and find apparent length of the apparent inclinations. Okay, so this is the expected outcome that we will get at the end of the video after projecting all these things into the CAD software, that is solid edge. Okay, so let's get started with it. First, before starting any diagram, before starting to project any equation that is given, we have to learn to set up the page. It is very important to set up the page because once you go to print, you won't get the diagram if you draw it outside the box, that is here. We want all the diagrams to be inside this, and the page that we prefer is A4 size. So we go to the sheet setup. Here we select A4 sheet and we remove the background. Save default and click OK. So now we've created a A4 size sheet in which we can start our diagram and start drawing. First, we'll use line and always use a thin line for the XY line. Okay, so this is our XY line. We'll just mention it. This is X and this is Y. So now let's get back to the question. What does it say? A line AB 80 mm long has its end A 20 mm above the HP. Okay, so now let's mark it up. This is our VP, vertical plane, and the below one is our HP, that is the horizontal plane. It is distinct here that this is VP, this is HP. Now the line that we have is 20 mm above HP, 20 mm above HP. So we'll just set it to 20. There goes our 20, and 30 mm below VP. So we'll just set another line to 30. There goes our 30. Now we'll draw a locus line to this particular point and also to this particular point. This locus line can be of any extent. You don't have to set a particular length to it. There it can be of any length. Now it says that it is inclined at 30 degree to HP and 45 degree to VP. 30 degree to HP. The line 80 mm. The 80 mm line is inclined at 30 degree. So now let's go. Change the length. This is 80 mm and we'll set the angle as 30 degree. There goes our 30 degree, 80 mm. In the same way, 80 mm and inclined to VP at 45 degree. So as we don't get 45, we use minus 135 or minus 145, sorry, minus 45. Okay, we get here minus 45. So now we get 2 points. Yeah. Next, draw the projections. Okay, so now let's start projecting this thing. Use the line and we'll extend this line to this thing, to this particular locus of B, locus of A, and locus of A dash. This is our A and this is our A dash. So this is the locus of A. We'll extend this line to locus of A and we'll extend this line to locus of A dash. And now as we've got this particular line here, we'll draw another length that is from here. This is another locus. just extend this thing. Okay. All right, so we've got this thing. This is locus of A. I'll just mention it. And this is locus of A dash. Okay, good. Now we'll use arc by center point and then measure this distance and draw an arc. You can see that it is the perpendicular. It is crossing there. Let me just change the thickness of this. Okay. And in the same way, arc by center point, we use this distance and we'll cut another arc which goes up to here. Good. Now we'll extend both the lines. We'll join both the lines. So if we join both the lines, you can see that we're getting a straight line. That means it is correct. So now we'll join this line to this and then this line to this. And now let's mark up everything. We use the distance between and we'll calculate what is the distance. Or we can use smart dimension and just add this, and you can clearly see it is 80. And the distance that we are getting here, 68.89 mm. This is clearly 80 and this goes are 56.65. And now we'll just mark the angles as well. So this is basically 30. At the starting we had taken it. This is 30 and this must be 45. Okay, this is 45. And now we'll have to measure the angle that we just got. So it would be this to this. We got 45 degree here. Good. And we get this thing to this. We get 55 degree. So this is the basic projection. And now for the marking part, you can say this is B dash, B1 dash, B1, B. This is our B. This is our B1. This is our B dash. And this will be our B1 dash. Now this will be the locus of B dash. And this will be our locus of B. Okay. We got it. This is the projection that we were looking in the very starting. So let me just compare it. Here you go. You can clearly see it is of same. Got 56.57. It doesn't matter because you have your own scale. You're doing it on your own, and this is the different. It doesn't matter. Here we get it 55 degree, 45, 30 and 45. This is the locus of A dash, locus of B dash, locus of A and locus of B. So now, as we cannot mark, I'll clearly say it, alpha, this is our alpha, that is 45 degree. This is our beta, that is 55 degree. And A dash, B dash is this thing, 56.65. And AB is 69.28. So I hope you guys understood how to draw this thing into the software and it was clear to you. And if it did, so please like the video. And yeah, I'll see you in the next video. Thank you.